So when you guys get to the point where you do the test, you are allowed to use your calculator for basically 2/3 of the test. When you do multiple choice questions, you are always allowed a calculator from here on forward. So in maths methods, specialist maths, you're allowed a calculator in any section that is multiple choice or extended response. The only section you can't use your calculator is in the short answer component of an assessment task. So let's have a quick look at just how I could have done some of these skills on our calculator. So if you want, you might like to do some like mad little scribble notes. But I do have some notes that you might want to add and glue into your summary journals later. I'll show you where they are in the lesson slides so that you can open them up at a later point in time. But, okay, so our calculator looks like this. The first thing that we had to do, or the first thing that most of you did, was you found the graph. You sketched the graph. To sketch a graph, hopefully I'm not in the way, I'll sort of squat down. Home. Again, I don't use Scratchpad. If I'm working in two documents, I like it to sort of all link together, so I use the graphing tool down the bottom, and then I always just work in a document. And then if you want to sketch your graph, I hope that you all know this. You can just type in your equation. One of the big things that you need to remember, this is what we call function notation. So we call this f1 of x. The fact that there's an x there means that you need to have an x in your equation. X is the variable. If you ever get a question where your variable is a t or a p or any other letter, and you're trying to sketch the graph and you're using a letter t or something else, your calculator won't know what to do with it. You've got to use an x. All right? So, minus 3x plus 8. There's my graph. All right? But we kind of get to the point where, I can't see the whole graph. So you folks need to get better at being able to quickly change your scale. I feel like the easiest way and the most consistently works all of the time way, menu, window zoom, window settings, my X value minimum and maximum is fine, and I'm just going to put a little scale marker every one. It's my Y value that's not enough. The bottom end was fine, but we needed to go higher at the top end. And then I'm going to put a little marker every one. So that scale is just where you have your little markers. Sometimes what is really useful, if you're trying to work out where the turning point is, it is really useful to turn on the grid. Menu, view, grid, lined grid. So now I can actually see the turning point is absolutely at 3, 8. All right, so that can be really useful. If I wasn't quite sure where that turning point is, my calculator, the graphing screen, can do a few things for me. It can actually find out where all of these points are. Menu, trace, graph trace, and you can see it has immediately jumped to the y-axis intercept. So when x is 0, y is -1. As I scroll across, remember we talked about having zeros are the x-intercepts. If your calculator comes up with this little thing in the trace function to say that's a 0, they're telling you that's the x-axis intercept. This coordinate doesn't look like a 0 though, does it? Right? This is 1.099912 e to the -12. This is scientific notation. Have you guys done scientific notation in science? No. Yeah. Not at all? Never seen scientific notation before? One person. 1.099 e -12 means 1.099 times 10 to the power of -12. Now, 10 to the power of -12, it's telling me that it's actually 1.099 times by 1 over 10 to the power of 12. Remember our negative index laws? We drop it to the bottom and make it a positive. So if we times it by this really small fraction, 10 to the power of 12 is a 1 with 12 zeros. How many am I up to? That's 12. And if I times by 1, what is that, 12 zeros, billion, trillionth? Right? If I do that, what that actually does to my number is it moves the decimal place 12 spots this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's actually 0.0000000000000 11, 1, 0, 9. Now, in my world, that number's close enough to 0. Yeah? The reason the calculator does this is because it uses what's called an iterative process to work out where it crosses the x-axis. It basically says, try this number. If that doesn't work, try this number. If that doesn't work, try this number, 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 try this number. And it basically repeats that really quickly in the background until it gets close enough. So sometimes you'll get these funky numbers for your axis intercepts. But the x value is 0.17. Keep scrolling across. I'm just using the arrow button. It should jump to the maximum, and it normally says a little max here. I don't know why my calculator's not doing it. Sometimes it gets a little bit freaked out. I'll show you another way to get it to confirm in a minute. Scroll back down and it should give you your other 0, 5.82, so there's your other x-axis intercept. Because it didn't get the maximum, I can go Menu, Analyze Graph, find the maximum for me, please. Lower bound means choose a point before it, and then I just hit Enter. And then it says upper bound, choose a point after it. So I then just scroll across to a point after it, and it will mark the maximum on there for you. So there's a few things we can do in the graph screen. As I've said since the start of the year, if this was your new mobile phone, you would have been playing around with your settings and playing around with the different functions to see what it could do. You've had that calculator this year. Some of you had it last year. If you haven't played around with the menu functions and looked at what it could do, start doing that now before exams and tests at the end of the year. All right? The worst case scenario is you change the settings and make a mess of it, and then you get me to help you put it back to factory settings. Like, it's not going to be the end of the world. We can do that really easily. Okay, so that's the graph screen. We can get our graph. In the normal calculator screen, we can do a few things as well. The first thing, Menu, Algebra, Expand. In all of those questions, you had to go from turning point form to standard form. So if I had turning point form, x minus 2 to the power of 2 plus 1, hit Enter, your calculator will just expand it for you. All right? If you had something that was already expanded, you know that you can factorise, don't you? So at the start, Menu, Algebra, Factor. I did that in a weird way, but you get the idea. Difference with factorise, I've got to put the comma x. Here's the other one though. If I have it in standard form and I want to get it back to turning point form so that I can work out where the vertex is, I can go Menu, Algebra, complete the square, and then type in my equation, x to the power of 2 plus 5x minus 6, comma x. It actually completes the square. It does the first part of completing the square for me, but what it's actually showing me is turning point form. So this graph, the vertex would go 5 over 2 places to the left and down 49 over 4 places. All right? They give me the coordinates of the vertex when it's in turning point form. That's what we learnt last lesson. So there's a couple of hints and tricks that we can use. If I want to find out the x-axis intercepts, how can I find out the x-axis intercepts? We don't know that yet because we're going to learn that today, and I'll show you how to do it on the calculator after we've done it by hand. All right. So let's close down that. Let's go back to our slideshow. and let's continue the lesson. What we're going to focus on now for the rest of today's lesson is how do I find or how do I sketch a graph using the x-axis and the y-axis intercepts. Yesterday's lesson, we found the y-axis intercept. How did we find the y-axis intercept? What did we do? We replaced the x with 0. If I want to find the x-axis intercepts, hey, guess what? We do the opposite. We replace the y with 0, or we substitute y equals 0 into the equation. So there's 2 videos here. If you want to watch them do this in the background, I'm not going to play them, but they're there for you if you want to have a look. We're going to jump straight into an example. Okay, so what we're doing, if you want to copy these notes into your summary journal or your workbook, we're going to look at sketching. So we're sketching parabolas using x and y intercepts. So that's our heading. And one of the things I spoke about yesterday for our summary journals is what I would like you to start writing down is when to use each of these strategies. Okay, so when do we need to use this strategy? The best place is when the equation is given in standard form. Or in the form y equals ax squared plus bx plus c. All right, let me grab some whiteboard markers. Okay, so this is my first example. We want to sketch y equals x squared plus 6x, and we want to show all important features. Yesterday, we were sketching graphs when they were in turning point form. So the first question you've got to ask yourself, is this in turning point form? Remember, turning point form looked like this. Y equals a x minus h squared plus k. Does it look like that? No, because we've got this extra x in here. So this equation is in this form. It doesn't have the c on the end though, does it? No. Right. So when I sketch this type of graph, the first thing I'm going to do is I'm going to find the y-axis intercept. And the way I'm going to find the y-axis intercept is I'm going to substitute x equals 0. Which makes my equation look like this. 0 squared plus 6 times 0. I'll put a little time sign. Okay, what's 0 squared?
0.
And then what's 6 times 0? 0. So this is just y equals 0. So this will be my y-axis intercept. Okay, the second thing I'm going to do is I'm going to find my x-axis intercept. My x-axis intercept. Now the x-axis intercept, I'm going to substitute. What am I going to substitute?
Y equals 0.
Y equals 0. So when I substitute y equals 0, my equation becomes 0 equals x squared plus 6x. And now I have a quadratic equation to solve. And we learnt how to solve quadratic equations. What technique did I use to solve quadratic equations? Keep talking. NFL, not the National Football League, but the null factor law. So we've got our null, we now have to factorise this. So, how do I factorise it? I'm not going to make x squared equals 0. I'm not going to make anything equal 0. How do we factorise? What's the first thing we want to do when we factorise? We look for a highest common factor. Does this have a highest common factor? Yes. X. So I take the x outside of the brackets and then I get x plus 6. So I'm now factorised. And then the null factor law says if I am multiplying two things together and the answer is 0, what does that tell me about those two things? Beautiful. One of them must have to equal 0. So either the first one equals 0, so either x equals 0. Now this part's complete, isn't it? There's nothing more to solve there. X equals 0. This is my first x-axis intercept. All right, this is my first x-axis intercept. Or the second part equals 0. And if x plus 6 equals 0, what does x equal? -6. Excellent. This one is my second x-axis intercept. Right, so now that we've got our x and our y-axis intercepts, let's start sketching our graph. The first thing I'm going to do, I'm going to draw a nice axis. I'm going to use the grid in my grid book. I'm going to rule it if I have to. I'm going to put the arrowheads on the end and I'm going to put my x and my y there. And then we can start marking these points. So the y-intercept is when the y-intercept is at 0. The x-intercept is also at 0. The other x-intercept is at -6. So here, this point, -6, 0. This point, 0, 0. We're going to use these 2 points to sketch our quadratic equation. Now I have to think about this, and we've got enough information to do this. I just have to think a little bit further. Is this going to be a positive quadratic or a negative quadratic? Why do you say negative? Because it was a 50-50 chance and you took the negative option. I'm going to say it's positive. Why am I saying it's positive? All the numbers are positive. More specifically, the x squared term is positive. This has to be a positive parabola. Which direction do positive parabolas go? So parabolas can either go that way or they can go that way. The first one. These ones are my positive ones, aren't they? So this is positive. So my graph has to go through those 2 points and it has to look like that. The only way my parabola is going to work is like this. All right? Okay. These questions take a while. I am not finished yet. The reason I am not finished is because it says show all important features. I've got my x-intercepts, I've got my y-intercepts. What am I missing? The vertex. Beautiful, we got there. The turning point or the vertex. So we want to find out what the coordinates of this point here is. Okay. Now, there are several ways we can do that. I'm going to do the most logical way on this time, and I'm going to see if you can even guess what the most logical way is. Can anybody tell me what they think the x coordinate will be? Why did you get -3? You are 100% correct. Why does it have to be in the middle? You're still 100% correct. Parallel is not the word I'm looking for. It's symmetrical. So my graph will always be symmetrical either side of the axes of the axes of symmetry. So this has to be -3. All I did was find the midpoint between those two x-axis intercepts. I want to find out the y value when x is -3. Find y when x equals -3. Would anyone like to suggest how we find out what y is when we know x is -3? Peyton? Y. You're 100% correct. We're just going to stick the x equals -3 into the equation. Why are we doing that? Because the equation helps us find y when we know what x is. That's exactly what this equation does. It finds out what y is when we know what x is. So let's substitute. So find that. We're going to substitute x equals -3, which looks like this. -3 squared plus 6 times -3. What's -3 squared? 9. What's 6 times -3? What's 9 plus -18? So then that has to be -9. And we've got all of our important features. If this question was on the technology-free part of the test, that is how you would do it. If this question was on the calculator part of the test, you would just go to, I'll actually run through it. If this was on the calculator part of the test, you would go to your calculator screen. You'd press tab to get the little entry bar in. I would arrow up to go back to equation 1. We don't want that equation, that's the old one. Get rid of it. And then let's just type in our new equation. So it's y equals, we treat that like our y part, all right? So that's like y. X to the power of 2 plus 6x. Hit enter. It's not quite on my screen, so I can go menu, window zoom, zoom settings. The x values are fine. We need that y value to be a little bit lower. So we can just play around and try a few numbers till it fits in. And then menu, trace, graph trace. That's the coordinate 0, 0. And now I'm just arrowing across. That's the coordinate of my turning point. Again, I don't know why it's not telling me it's the maximum. I think that's my computer. And then there's my other x-axis intercept. All right. So we can really quickly do this if we're allowed to use our calculator. We only have to do all of those steps when we can't. Okay, I'm going to stop the video. I want you to try this question on your own. So that one, have a go on your own, please.